I think you see my browser now. I'll just move that. And right, so here we are. At the moment, we are getting close to 4 p.m. UTC. And our plan is to not have a break at the moment, but just continue the discussion, like a broader discussion of RAGs and LLMs. And I'm glad that Owen is here, and maybe Paula is here too, and also Siavash of the earlier talk today, so we can have a broader discussion of these topics. And after that, we'll have some more free-form chat before the next session. So yeah, just wanted to kind of share that. And yeah, so it is a moment to expand. And unless maybe Owen, of course, you're part of that, so maybe you wish to add more. And yeah. I think there were a few points earlier by Peter and Paula that we kind of stopped because of time, and maybe we can return to that or think together about our hopes for research projects around LLMs and RAGs, which have been the topic of a few of our talks today. And maybe Siavash, you have some thoughts. Oh, Paula is here. Wonderful. Yeah.
Yes, I'm here. I did answer a little bit in Zulip. I can't right now. The reason I'm off camera is because I had to drive my daughter to work. I've just dropped her off and I'm coming home now. But I'm certainly available to talk.
Yeah, wonderful. Yeah, and maybe I'm wondering, Owen, did you have anything to say more about your project that we kind of stopped because of this shift? Did you wish to continue on something, or?
No. Yeah, no, it's. I guess there's an open question there about using closure for these kind of projects. Like I said, I was surprised how much you could do with closure, but it was definitely a bit of a learning curve at the start, because I actually wouldn't know. Like, I'm probably rare in that I only really know closure. So there was a bit of like learning Java and Python and things like that. But I don't know if that's a question for other people. Like, how do they feel working with LLMs and closure, or is there scope for like libraries there or frameworks or
I think this is a really interesting observation. I was actually thinking when I was watching your presentation, hang on a second, is it the case that you needed to be across closure, kind of Java a little bit because you're using Lang4j and Python in order to solve your problem?
Yeah, exactly. Yeah, and
yeah, that's a problem.
Yeah.
That's I don't know who that's going to work for. This is something that needs to, where we need to focus our attention, I think.
Yeah, maybe Lorelai, if that is okay, I'll use this opportunity to say a bit about our AI study group, which is kind of related to this session, and hopefully it will encourage us to expand the discussion for a moment. So I think, that's something we have been running in the last few months, and usually we meet every couple of weeks and have a talk or a practice session or a few talks where we look into AI related projects in Clojure, usually in Clojure. And some of these projects are very much about composing APIs, as Owen said, but sometimes we're also wondering about our workflow and the way we compose things. And one of the special talks we had there was by Siavash, who also present some of that today. And there has been a hope to turn that more into a research group. So it will not be just a space where people can share what they do in the open, but also an ongoing space where we take on projects and explore them in between. And a few weeks ago, we had this session where we had Siavash's great talk. And then after that, we had an unrecorded discussion, which was kind of inspiring because a few people had ideas about what we could explore in the form of a study group. And maybe in a moment, Siavash, you would like to add something about that. But yes, I think logic programming was one of the directions that felt like we could explore more at, and based on your experience, Siavash, that you shared today, but that we could possibly do that in the open. And maybe it is a moment we could think about what people here may like to explore and whether a study group in one form or another could be helpful for that. And I think a few people here have been looking into composing these systems at work. And the question we are asking is how we can do it in the open so we can learn together. And so that's like a proposal for this session of something we could think about. And I imagine, Siavash, you may have something to add if you like.
The first thing, I think, making a stream, and I share some concept tools and techniques which I'm using, and also putting them on the notebooks, so we will access to the shared resource, so we can play together the possibilities around the logic programming. About research could be done in different level. For example, building proof of concept of combination of large language model and logic programming on different domains is practical and applied research. Building proof of concept. This kind of things is research, but very applied and very business focused. There are some other research like you could go inside the logic programmings. This is more computational science research. These kind of research are also interesting. For example, when Paula was explaining the embedding vector, for example, queen and monarchy, woman, means if we add these two vectors, we would conclude the queen. I was thinking, if could we explain the logics instead of Boolean logics as a vector logics? If we can do it, how could we do induction and deduction with it? So there is a infinite amount of space for research. Another direction, another special thing is, could we, which somehow we could use the embeddings, could we make logic programming a superset of logic induction and reasoning, which could combine different reasoning techniques like fuzzy reasoning, normal Boolean reasoning, rough set reasoning. Could we find a model which is superset of these models and we unified them all under one model? These are some computer science or pure AI things. But at the same time, there are lots of applied or practical proof of concept we can build together. So the first step is creating a stream or thread, and we ideate around what we want to build, and after that start building based on the maximum vote. Start building it, showing it, and so on.
Yeah, thank you, Siavash. Yeah, I think that's so helpful, the way you view this process. And probably in the next couple of weeks, we will just try to pick a modest version of one of your ideas and try to see how we explore that as a group, how we bring that to the study group and so on. And yeah, and I think in general, since we're talking about having another conference, I think Lorelei, we had a few chats about this, right? About how we could repeat this process again till September or something like that, where we'll have another conference with other projects which are of a broader scope. It is a good moment for people to begin a research project and not be alone, and be part of a group, think together, follow up every week or two, and bring something to completion or to a certain stage by September, and then share it in some form. And so if anybody is looking to begin a little research project, let us chat about it and see how it can connect with our path as a group.
Yeah, I'll tag on to that just because you did mention me and what we spoke about. And I feel like I'm being kind of quiet right now because this is far from my wheelhouse. I know very little about LLMs and stuff compared to the people who are like working in the field or who have worked with them. I have done a lot of other things, and I actually have had a pretty interesting experience kind of getting towards agents and interviewers in one setting, but I ended up getting sidetracked and I started working on RDF, and I basically started trying to use Aristotle enclosure, and that was its own kind of realm. And I'm bringing that up because Sivesh, when you mentioned like unifying these different models, it kind of reminds me of the semantic web, like a semantic web for like AI models almost, and like creating a logical system like Dolce or like OWL, which are like cognitive linguistic models for like semantic reasoning essentially. And I think that these things are all really interesting, and that it would take teams of people to do that. So then bridging that to what you just said, Danielle, about how like this is definitely something like looking towards the future. I'm really eager to hear more people talk today and tomorrow, and I'm already thinking about what I'm gonna present in September. Like I'm gonna definitely expand on what I planned on showing this afternoon. And then just the last thing is that there's also the collaboration piece, is that I'm hoping that I can definitely recruit people to help me on the kind of brain things that I'm interested in. And it's great to get to sit here and listen and learn from all of you about RAGs and stuff. Like I have very little knowledge of RAGs in general. I've heard of the term, and then DAGs are like another thing. I don't know if they're like related at all. I've heard of it, but I'm kind of unfamiliar. And so, yeah, it's really interesting. And thanks for sharing.
Since you mentioned RDF and OWL and all that, is it okay to say just a little more about that in case it is unfamiliar to some of us? If you wish, if you could.
I feel like it's not really super relevant. It was just kind of the fact that that was going to be applied to querying vector stores, and that's for an AI project. But I didn't really touch the AI stuff. I was actually recruited for more of the actual like well, actually I was kind of, it was more just me being a generalist than anything. But I got into Aristotle for a second, and I guess to explain those really quickly, because it is a whole wormhole, is that in like 2012, I think it, or no, 2002 actually, this organization basically decided that they were going to take it upon themselves to define the semantic web. And these were supposed to be kind of like ontologies for capturing everything, like a linguistic ontology that can essentially computationally describe any context. And there were 3 different leading solutions for that problem. One of them was Dolce, which is the thing that I was most familiar with. It's like its own paradigm. And then I mentioned OWL, which is kind of unrelated to what I'm going to mention. I might get to it, but there's BFO as well, is the other leading one. So Dolce and BFO. And I'm forgetting what BFO stands for right now, but Dolce stands for the descriptive, ontological, linguistic, cognitive engineering, and essentially it lays out a humanistic way of perceiving the universe, whereas BFO, which is the other perspective on this, because there were 3 actual leading languages, the other one's Ochre, and I didn't study that one at all, but BFO and Dolce are 2 different approaches to contextualizing reality through computational logic. And so I studied Dolce, to say that again, because I know this is a lot of different words I'm throwing out there. Dolce is the one that I became most familiar with, and I could actually share the paper that it's from, if I can find it. I'll pull that up when I'm done talking and I'll share it. But there's like a Dolce paper, there's actually 2 really good ones that I read, and the idea is that BFO is describing things like temperature in terms of Kelvin, and Dolce is describing temperature in terms of like, well, this is when we perceive water freezing, and that's what Celsius is. And so they come up with linguistic categories for what these things are, so that you can actually create a logical framework for English sentences and for actual reasoning. It's supposed to lay the foundation for a lot of AI, as far as I'm aware, but it also does a lot more than that, because it presents an actual symbolic logic to represent rational thinking, essentially. Let me see if I can get the paper, because I actually do have it here, like quick loaded. Do you mind if I share my screen since I'm talking right now?
Yeah, that would be great.
Okay?
And maybe I'll just say before, I think it is kind of nice that we diverge slightly from the original scope of this call, and it is kind of an opportunity. By the way, we have at the moment also Sivaram with us, and Sivaram has been very much looking into ontologies and various aspects of them. And of course, Sivaram, if you wish to say something, then it would be lovely. And yeah, so I'm glad we're taking an interesting direction for a moment.
Well, this is basically what it looks like, and I don't want to like take up too much time. I feel like, because this is supposed to be a discussion, and I'm not trying to present on this, but this is symbolic logic, and so it actually, like, I feel like inherently looks more complicated than it is, because actually this particular page is surprisingly simple in what it's conveying. And so you can see axiom 1. When they say axiom 1, they're actually referring to the original Dolce paper. What I have on the screen right now is something that was written in 2022, so this is pretty recent. I'll just go back up to the top. This is pretty recent. What year was it? Well, 2003 is the original Masalo paper. Anyways, these people are just conveying what was written in the original Dolce paper, but this is a fantastic explanation of everything in there. If you're really interested in the original one, then well, okay, I don't want to get too carried away. Anyways, so temporary part typing, this is describing like something literally being a part of another thing, like composition. And so what this is saying is that there's three things that go into something being a part of another thing. And what those three things are is that an endurant is with another endurant for a portion of time. And I know that that probably doesn't make a lot of sense out of context, but what it's saying is that X is a part of Y for time period T. And that is the definition of parthood, is that something is a part of another thing for a period of time. And so they're encapsulating an actual idea, like an abstract concept of parthood in symbolic reasoning. And they go on, that's one axiom. They're basically stating like, this is our definition for parthood. And this axiom is like the actual like sort of kind of logical proof for that. And then and they explain these below. It says axiom 1 states temporary parthood. It holds only between two endurants at some time. And so they're using these words endurant because they mean it very technically. I skipped over the beginning of this paper, but if you zoom in at the principles and structure of Dolce, it's not zooming for some reason. Let's do this. You can see that there's actually 4 main categories. This is kind of a lot of information to take in, but there's endurance.
Maybe, Lorelai, maybe if that's okay, I'll stop you for a moment and I'll just say that I think I did lose you in some of the details. And since we have time at the moment, it might be good to maybe even slow down for a moment and say why we're looking into that, and maybe actually go a few steps up and kind of remind us of the context of what this paper is about. Is that okay? Because we jumped forward maybe a bit too quickly for me, I think.
Sure. Let's try and open this. This is the original WonderWeb project, and this should explain a little bit more specifically or clearly the overarching goal here. I'm going to share this in the chat if I can. This is the original Dolce site, and they have the paper on here, I'm sure, just like directly linked. WonderWeb deliverable 18. Let's see if this is it. Yep, this is the original paper. And so if you're really interested in the underpinnings of all this, I shared the 2022 paper because that's specifically designed as like an introduction to the logical reasoning part of it. But if you really want to get into like the philosophy of like why it exists, this original paper is probably better for it. They have the role of foundational ontologies here. And as I was mentioning earlier, it's the basic infrastructure for the semantic web. And so what does the semantic web mean? Well, to me, I think it's a little bit of a loaded term, but like, because I just don't think that there's like one clear definition, but I consider the semantic web like, I guess, the actual context of everything on the internet and in data space that's like shared in their relations specifically. And so the ontology is aiming to categorize the universe in these helpful ways. And Dolce is doing it from a specifically human point of view, like I was trying to explain, where they're trying to categorize these things from like, oh, we perceive parthood as being this relationship through time, but BFO approaches things very differently, and it's supposed to be more scientific in that way. And I'm kind of unfamiliar with how they approach these things because they're whole like domains of thought, to be honest. But I don't know, was that a decent enough explanation as the philosophy? Is that this is basically supposed to be providing an actual logical foundation for reasoning computationally.
Yeah, I think that's helpful. Thank you so much. Maybe I'll just say, looking at the clock, that the plan for now is to end this topic and take a short break and turn that into an open chat, which is hosted by Lorelai, I think. So we can talk about anything in a moment, and maybe stop recording for a moment, so people can kind of get slightly more comfortable, and then afterwards we'll have another background session. And maybe let us, before we go about that and kind of end this session, let us think if anybody thinks we should return to something that was missed in Owen's talk or Paula's or Sivayash's talk about the different talks about language models and RAGs we had today. And maybe we can kind of conclude this part in a moment, if it makes sense.
Could I just ask Siavash a quick question?
Yep.
Or you mentioned that in your work, which was really interesting, by the way, thanks for your presentation, that some of the end users were the ministers themselves. So I just wondered how did they find that, like, working with the large language model to interact with the data? Like, how's the feedback? How has it been in terms of from the policymakers?
It is not yet completely delivered. So the first part is delivered, but the second part, which are what should I say? The managers is not yet delivered. I should educate them how to ask things, and also teach them some data science terminology, like using word cluster and so on. So it is not yet delivered to them and getting feedback from them. But based on the first session that I delivered to their technical people, the overall atmosphere was pretty positive.
Yeah, it seems like it could be a great tool for them. All right. Yeah.
Yep, because in governments, when everything is slowing down, like turtle or snails, when they want a report, it takes a month, it takes a week. So it is really interesting for them if they can ask question and get the report. Oh, it is like magic for them.
Yeah, so sometimes there's good reason that it's slow. Like maybe it's like, yeah, I know that, because from my perspective, like if you could reach out to an agency and query their data, and it'd be such a huge game changer. Because yeah, usually it can take like 6 months, 8 months just for simple queries. But then sometimes I wonder if there's a reason that it's slow, that it's the system has to work that way sometimes when it's that kind of centralized government system. But yeah, it was really interesting promise of your project anyway. I'd say lots of policymakers would love to get their hands on that kind of functionality.
Big enterprise, any big enterprise, governments are the biggest enterprise, have tendency not sharing data with each other, because data and information are source of power. So we have information silos in any organizations. And these using LLM and this trend, which is using AI query data and so on, automatic data analysis and so on, by the time somehow remove requirement for the middle analyzer in the bureaucracy. And also somehow merge some of organization together because there is no need for workflow for analyzing and so on. All of them could be done by the AI.
Yeah, it's fascinating. Thanks so much.
Yeah. Yeah, so let us think maybe. Yeah, and thanks so much again, Siavash and Paula and Owen and Lorelei for this improvised intro to ontologies. That was so nice to have it as a surprise now. And yeah, maybe Lorelei, let us think about what we could do now. So I think the plan was to stop recording soon, maybe, and have like an open session till the next till like a little more than half an hour away. That will be 5 p.m. UTC, and then we'll have another background talk. So should I stop recording and we'll keep chatting as much as we like? Is that good? Yeah. Yeah, thanks.
Hey, Daniel, I have a question.
Oh, hello, Sivaram.
Yeah, hi.
Hi.
I'll turn on my camera. Hi. So this is a question for actually, I think maybe Paula. I know Paula is deeply involved in the semantic web space, and I really liked your presentation on LLMs and RAGs. So the question is, are you currently using any of the semantic web side of your experience with RDF and ontologies with the LLM kind of thing? Because there's a huge amount of noise when it comes to LLMs with knowledge bases. So I'm curious if you've done any work in that and what your thoughts are.
Yes, I don't have talks on it. I was doing work in this, and this is what has led to me becoming a full-time PhD student. I still work full-time for RDoc, so I'm working and studying at the same time. But yeah, there is a lot. I mean, Lorelei was speaking earlier, and I was trying to be very polite and careful and not step in. I saw that you mentioned that BFO is basic formal ontology, so I grabbed the book on it.
Yeah, I have that autographed by Barry. So I'm very much involved in the BFO community and have been for close to 15 years now.
Okay.
Yeah.
So yeah, there is so much from different directions. I originally approached it because I was working with SNOMED, which appears in an ontology as OWL. And so it's already in the graph format, but it's representing a description logic representation of that medical domain. For people who aren't familiar with this, OWL is a language for expressing an ontology. So other systems like BFO are going to be, they are ontologies that they're going to be making declarations of logic and things like this. Whereas OWL is a syntax for representing it. And when I say syntax, it's a conceptual syntax because it has a number of serializations, one of which, importantly, is RDF. So you can represent OWL in a graph, and it will then be describing graphs separately. So you can have a text description of OWL, which describes a graph, or you can convert it into a graph and it describes a graph. But what OWL does is it goes from simple things like declaring these are classes of things, or this is a class which inherits from those, or it's an intersection of this or union of those. And then it can start saying, well, here are the properties. And to be a member of this class, you must have a property that connects you to a member of that class, or you must have a value property which is in this numerical range. All sorts of things like this. It's a very comprehensive way of describing data in general. And it was specifically oriented towards RDF, which is a graph format for data, but it can also be viewed as logic, statements of logic, that this thing exists and is a member of this class. This thing has these properties associated with it. So it operates both as logical statements and as a graph structure or data structures in general. RDF is very flexible this way. And SNOMED, the systematized nomenclature for medicine, clinical terminology, so SNOMED CT, is a description logic framework for describing everything we know about medicine today. And it's enormous. It was released every 6 months, but with the coming of COVID-19, it shifted to every month. And there's a committee, it's a non-profit that manages it. They have doctors and clinicians from around the world who contribute to it, and it's constantly evolving. But it describes every disease that we're aware of and what goes into making up that disease, what makes it this disease and how it's related to other diseases, and plus all of the biological systems we know, plus all the drugs we know and things like that. There are other data sets which describe similar things, like all of many
Loink and RxNorm.
Loink is for labs. RxNorm is for drugs, and there are links between them. RxNorm actually references is the ID in SNOMED, for instance. And I mentioned in my talk ICD-10, which is describes the clinical diagnoses. It's an international standard, and they are related to SNOMED, and they connect with SNOMED. And you can download data sets which connect ICD-10 to the data in SNOMED, although ICD-10 itself isn't in RDF. However, ICD-10, the format, the structure, the standard was released in the 1990s. It's only been recently adopted in a lot of countries, like the United States was about 10 years ago. But a few years ago, ICD-11 was released, and it's building out at the moment. It has mappings back to ICD-10, but ICD-11 is defined in RDF. And eventually we'll all move to using that. Now, reason for mentioning all of this, I was working with an RDF representation of ICD-10 and SNOMED all joined together, and I was supplementing, I was doing graph RAG in this, so that when I had an LLM look at clinical notes, it would try to interpret what the clinician's text meant and try to interpret what the appropriate ICD-10 code might be. Now, it's terrible at getting codes, because I mentioned earlier, when we encode those codes, they're just random letters and numbers from the perspective of the LLM. And so it's really the labels which we can attach to much better. And so I was doing semantic searches across labels and then attaching it in. And I got better results if I could say, here are the clinical notes, let's pull apart the sentences, get the vectors for those, look those up on title or description out of SNOMED, and then get the codes there. What does that connect to in ICD-10? And pull out that subgraph of all that representation, and then present the subgraph along with my query to the LLM saying, here is my, here is a clinical note, here is some relevant data. What can you tell me about this? And I would pull out a large enough subset of the graph, so several different things, and say, what does this best relate to? What are the appropriate codes for me to use? And having this sort of interaction between the really tightly defined description logic of the medical domain, along with the LLM's ability to parse through clinical notes,
this was a very powerful combination, and it's what a number of startups are trying to compete against established companies with at the moment. I was working in that space and decided to enroll at university to continue on, like do more in it. And the company I was working for just found with so many people using LLMs to try to enter this space, they were having to consolidate everything they were doing. They let me go. So this is how I've ended up at RDoc. But it's still a really interesting space, and it's the foundation for my thesis. And like, there's a whole lot of other things which are coming up as well, because like I just discussed RAG, but we're talking about a description logic that comes from the OWL. How does that connect into it? And it turns out that LLMs understand the syntaxes between RDF and OWL really well, because they're all standards and they've been trained on the standards. Internally, Luke Vandehart at the last Clojure Conj discussed how LLMs actually seem to reason quite well around graphs. They seem to be a natural fit for LLM reasoning. And so that's a very interesting thing to connect in. And so graph RAG becomes more important in this space. You know, of course, LLMs like to work on text, while a lot of what we're working on is data structures and codes. Embeddings often help, and embeddings with vector databases help us go from one to the other. And so this is how we can glue those together. And what I found is that there are a number of elements of things like OWL which are intractable. I can describe certain logical constructs are not, which we can't solve in meaningful time. But if you present that problem to a large language model, because while the mathematical structure might not have a general solution, I can say, well, here's my data, here is the ontology that describes it that I can't generally solve for, but it'll work on this data set. What can you tell me? And it can actually do that kind of reasoning when we don't have any reasoners like rule reasoners or Tableau or any of the other known rule algorithms. Large language models are actually able to do that sort of reasoning. So they're bridging a whole lot of gaps that which have existed in this space until now. And at the same time, the inaccuracies which show up, which at the moment we try to correct using RAG, it's still inaccurate, it's still difficult. And my thesis is about trying to use not just an OWL description of something, but the description logic that describes something, and how I can modify that attention mechanism through the LLM. So where do I come into those matrix operations step by step with a description logic embedding that tries to provide guardrails as it goes, so that each step of reasoning is being guided by the description logic around it. I don't know if I'll be successful, but that's the direction of my research at the moment. So I know I spoke a long time. You asked, like, am I working in this? I hazard to say that yes, I am.
Yeah, no, thank you, Paula. I mean, definitely don't want to hog all of the time, right? But I think Daniel is getting a little restless there. But I definitely, yeah, this is amazing work, and I definitely want to follow up with you on this. Maybe connect outside, and we, and continue to follow this as you're going through your PhD as well. So.
Please, if I've raised any questions at all today, I love people getting in touch with me. I live out in the middle of nowhere, and I'm a bit isolated. I drive into the university a few times a week, but I love interaction if anyone wants to talk to me.
All right. Thank you. And thank you, Daniel, for patiently waiting.
Oh, that's what this time is for. I mean, I'm so glad we have this discussion, which was kind of initiated by Lorelei, and we had the luck of having all the OWL and ontology people around. So, yeah.